Now let me ask you a question real quick. How much would you pay for something like this? And what if I told you I was able to make and sell 30 of these in a month for 30 bucks a piece on nothing more than my Ender 3 3D printer? Now, as you may have guessed, there's actually a lot more to it than just pressing print. So let's take a deep dive into what it actually takes to make something like this, and then go over all of the post-process to see just how much money I can retain in the end. And let's start with that printer. This is my automated 3D printer. It's the OG original Ender 3 3D printer, and I mean it's pretty much stock, albeit a little bit massaged right there, here, and well, okay, it's not exactly stock, but in order to get this thing to print automatically and, you know, just queue up one part after another, there's not a lot to it. Just this glass surface right here is needed, possibly a little paddle on that, and then an OctoPi running a print queue software is about all you need. That, you got to run the right material. This is ABS. So I print something like this off in ABS, I let the plate cool down below 50 degrees Celsius, and then this thing comes down here and just pushes it off like so. And because I have a big box down here, that's where all the parts collect. The real question is, can I use something like this to make money? Spoiler alert, I've already made money with it, so I know that I can. The question is, how much? And can I come up with enough excuses to fill my house with 3D printers? So that's when I came up with this. His name's Sweepy. And Sweepy was a new character that was recently introduced in a game called Oxygen Not Included. And this little guy runs around and sweeps things up, and you can decorate it by storing things on top of its head. Turning this into a drink coaster didn't really stretch the imagination. So therefore, fans of my channel, plus fans of Oxygen Not Included, might find something like this desirable. So I made a video about it and asked people how much they would pay. And I also got the blessing from Clay Entertainment, and as it turns out, it looked like there was going to be enough margin for me to actually make this for profit. So now let's dig into the details to see just how long it takes, how much money I spend, and how much money I get to retain in the end. Now, before we get into all those juicy money details, let's talk about the design here real quick. Because the product I ended up selling, these guys over here, as compared to the prototypes, there were definitely some design improvements over the generations in order to make something that was efficient. So let's start from the very beginning. Prototype number 1. This is prototype number 1. It's printed in PLA and designed to be printed without any supports. To overcome that, there's a little overhang right here. I put a small fillet there that allows you to support that just enough to get the job done. Print off a couple of feet and stick them on the bottom, and boom, there you have it, a drink coaster. I colored this using some paint markers, just like so. And these are a great way to get a little bit of color onto a part like this without needing to change your filament a whole bunch of times or split it into different parts. I love using paint markers like this. However, it's not quite a professional finish. You know, it doesn't work as well as spray paint, and it takes a lot of time. If I had to make a bunch of these, this isn't how I'd want to color my prints. So that's when I came up with this. It's split into many different pieces that are bolted together. So it actually comes off the printer looking a bit like this. You have your base, the middle, the top, and then some feet that you end up fastening onto the bottom. As it turns out, this works quite well. It's fairly easy to put together, although it does weigh quite a bit. That's tipping in at 168 grams. Nice, although a little bit heavy. The reason that this is so much heavier than the first prototype here, which only weighs 118 grams, is because it's made out of ABS. Therefore, it has quite a bit more infill in order to deal with the top layers and bottom layers, of which there are quite a few more because these are all separate parts. That all adds up to make this print quite a bit heavier. Plus, there's a few fasteners inside of there. So to address the weight, that's when I came up with this design right here. It's the same sort of thing, albeit a little bit lighter, coming in at 143 grams. Same sort of design, just optimize the printing of this. The other thing I did is right down here on the bottom. In the previous design, I had M3 fasteners that would go down here, and then an M5 in the middle for both the top and bottom. I switched that to all M5 fasteners for the final release of that product. So rather than needing two different types of fasteners to put the whole thing together, I only needed one. So a few less operations to put the whole thing together. In the end, I ended up building 30 of these and selling them on my Etsy store. It worked out good. However, it could be a little bit better, which I'm sure you guys are already commenting down there. So one of the things I did is stuff like this. It's still the face, albeit weighs a little bit less. This actually allowed me to print the parts with more walls and a little bit more infill while still saving weight. The other big advantage here was that this is no longer bolted on. That is just printed in there, just like so. So that takes away about 4 fasteners, plus all of the tapping and whatnot needed to get all that to happen. And I got the magic number down to 106 grams right there. That, without all of the extra stuff on it, is under 100 grams of plastic. So this divides into 1 kilogram increments perfectly, which really weighs in on the whole money side of things. How many kilograms do you need to buy? How many of these are you going to make? And how much does that then sell for? Let's talk about money real quick. And in this example, if I was to sell 1 sweepie, that would be 1 complete pie. However, if I was to sell 2 of these, then I would be selling 2 slices of that total pie. So this is the total amount of money I'm going to bring in versus its value of how much each unit is going to cost. What I want to figure out here is at what point does cutting this pizza into more slices mean I'm not making any more money. So based on my results, ultimately I got 2 responses saying that they would pay $50 for one of these sweepies. So if I only made 2 sweepies altogether and I sold it for $50 each, the total pie here would be worth $100. So when you factor in how much plastic that is and how much time and effort it would take to make that, well, that would be a lot of profit. However, the total amount I'm bringing in isn't that much. It costs too much. The item is too exclusive for me to actually make a decent amount of income. So if we were to take that down to $40, you see that I might be able to take this and cut it into about 4 or 5 pieces. So now my pizza is worth $160. However, I've doubled the amount of work I'm doing here. Well, here I now have 8 slices, but each slice is only worth $30. So now my pizza is worth $240, but it takes many times as much work in order to make that happen. Having doubled everything again, you can now see that this is hardly even a pizza slice. You might pay, I don't know, let's say $10 for it. Ultimately, the pizza as a whole is going to be worth less, and the amount of work it's taken to make all of that has cost me quite a bit more. So while I'm not an expert at this, the trick to the whole survey, as far as I can tell, is finding the tipping point so that I can optimize how much work I'm doing versus how much the value of the item is. With that stuff in mind, let's take a look at the survey results. Over here are the responses, the amount that people are willing to pay versus the amount of people I can sell that to at that price versus the total amount of income from selling all of those. When we put that on a chart down here, there's a clear top. So everything to the right of here is more work for less total income. So the 2 peaks right here are $30 and $25. So from the looks of it, somewhere in that range seems ideal. Now when we compare this to what it costs to actually make the thing as far as the physical material, at a spool price of $17 per kilogram, and each unit consumes 130 grams of that, that comes out to $2.21. If I want to make a batch size of 30 units here, that's just under 4 kilograms of material. So that's how I came up with 30. So that means in plastic alone, I'm spending about $68. Not bad. The total print time is 24 hours, and that divides out like this. Now if we add in the machine cost here, it runs at 130 watts on average, at a cost of 7 cents per kilowatt hour. And then, after every 730 hours or so, I have a maintenance cost of an average of $22. I change out a nozzle every now and then, and some other parts might wear out. Meaning that the total out-of-pocket cost for just 3D printing the item is $3.15, which doesn't sound like a whole lot when you compare it to how much I'm selling it for. However, that's far from the only thing I need to do in order to make this a finished product that gets shipped out the door. So now let's shift gears and talk about the post-process, everything after the print. part like this is fresh off the printer. However, it's not yet ready for use or paint because we have this brim that I used right down here in order to get it to stick to the platform. So the first thing I need to do is remove that. Now, some of this you can peel by hand, just like so, but in order to get it really clean, what I'm going to use is this deburring tool. So this is the first operation and all of the steps that I need to do after we've completed printing the part. After deburring the part, the next thing I would do normally in my original design here was to come in and tap all of these holes. I found that I could use this in a drill and go quite quickly. So tapping all of these holes actually takes quite a bit of time, and the other thing that happens here is it actually makes for a lot of debris. I'm dealing with a lot of little chips here that would end up on these parts as they kind of build up static electricity, and it would just cling to them. So I'd have to clean the parts before it goes off to the next step, which is paint. So that's why the redesign of this part here to get rid of all tapping was so important. I don't need to tap these 4 holes anymore, and also the hole in the middle, I've sized it just right for it to be self-threading. But now let's talk about paint. It's the single most labor-intensive series of operations that I have to go through in order to make this thing its final shape. So being efficient when it comes to painting the parts is really, really important. To try to make printing this efficient, one of the things I did here is try to take a little bit of a dowel, and then I would put the parts on here like this, and the idea was to kind of suspend this inside of the printing box and then rotate it a bit like a shish kebab as I was printing. However, that didn't really work out all that well because the weight caused this thing to sag and it just didn't work as well. However, the second time around, what I did is I stacked these up vertically, just like so, used the rod to keep everything in place, sprayed one side, rotated it 180 degrees, and sprayed the other side. After spraying the sides, I would just unstack the whole thing, spray the top, wait for it to dry, flip it over, and spray the bottom. Easy. However, the most difficult part, and where all the time was spent, is right here in the middle, trying to get these face just right. In an effort to make this efficient and even work, one of the things I did here was make a stencil out of painter's tape, and this was cut out using my laser engraver. Now, how this works is what you'd end up doing is taking this little piece right here and then placing it on the face so that it revealed the eyes but covered up the back. However, placing this down exactly right took a couple of tries per part, and in the end actually took quite a bit of time, roughly about 3 minutes per part. So then once all of this is in place, you can paint this brown. And because I was using black ABS, all I'd have to do is reveal the eyes, just like so, and paint those green. And to do that, I was using a paint marker, just like this. But as it turns out, the paint marker doesn't really like to stick to the plastic all that well, so it would take several passes in order to get a nice even color. That's where a lot of the time was spent, just dabbing on the little green bits that ultimately became the eyes. On average, it took me about 6 minutes per part in order to get these eyes perfect. So the most important thing that I could do here to make this whole operation more effective is to streamline this process. So the second go around, that's where I came up with this right here. This is basically a stencil, and it sits on this base, which unfortunately didn't work out all that well. It broke coming off the printer, but the idea here is that the stencil clips into place and only shows the spot that I need to paint right here. I'd actually printed all of these out of white ABS, so everything would get painted brown to begin with, and then I would paint it black, and then I'd add the green on top of that using yet another stencil like this. So the hope was that this was going to be more efficient. Question is, did it work? Well, yeah, I think it actually did work. Once you kind of get this process figured out here, and you kind of figure out where to put your hands and make it work, I was able to spray this part right here in about 1 minute. So that's actually a couple minutes faster than putting the stencil on here. Plus, I don't have to cut this thing out in the first place. It's far from perfect, but the idea is pretty good, and it actually is more efficient. However, one thing that didn't work out here was doing the same sort of thing but with the eyes. As it turns out, this feature is just too small. A bit too much paint builds up or not enough paint builds up, At best, a result like this is about all I could hope for out of that stencil process. The eyes are a bit hazy, and there might be a little bit of overspray. Even then, the eyes are not that kind of green. When you compare this side by side with what I can get out of the paint pen, well, you can see that the paint pen is just a whole lot better. But here's the cool thing I discovered here. Now that I have a little bit of paint on here, this paint pen that I'm using to put the green on actually sticks a whole lot better. So rather than needing to make 4 or so passes in order to get just enough paint to be, to get a nice even color, this here goes on a lot faster and it sticks well to the base coat, which is that black color. So really just a bit like this gets you that first pass, and then I'll come along with the heat gun. And then I can get right back to adding the next layer right here. So there you have it. Not extremely fast, but a big step up from where I was. Now for the final 2 pieces here, the cork inserts for this part. So I've got a logo that I put up here on top, just like so. And then I've got 2 inserts that go right down here on the bottom that allow you to have a little cork on the bottom so that it's nice and soft when you put it down and it doesn't slide around. So this part right here just comes from Amazon, pre-made, and it has a little bit of a sticky back right here. So all I have to do is line this up in my laser engraver and then burn that shade in to the top of the cork material there. That means I could just place the cork inserts where they needed to go and then run the whole batch in one go. This works out really good. However, every once in a while, for some odd reason, the laser doesn't always engrave where it needs to be engrave. I don't know why it does this, but this leaves me with a little bit of scrap material. And that, ultimately, is what I end up cutting the base pieces out of. So what I've done here is just lined up a rectangle, and that's just a template for me to go in here and cut these by hand, just like so. And then I have that little rectangle piece I need, and placed right here in the base, like that. And once I have 2 of these, I flip it over and push down, and that gives me this nice even thud, and the thing doesn't move around. Great. One more thing I did here to make this a little bit more efficient between the 2 revisions was obviously these feet down here are no longer physically bolted on, they're just printed in. So I'm going to add the cork inserts here before I go and stencil it out and paint them black. So this will go right over here like that. And then I just paint all of this black. So that'll make this a little bit more efficient. In order to line this piece up here, because it would look bad if it was crooked, I ended up using my laser engraver to make this template. This template here goes over the feet like so, and will flip up just like this to line up my logo. So I think that's a pretty neat use, and one of many that I found for something like this laser engraver. Ha! So 1 clear coat later, and this part is now complete. It's rather humbling when you step back and you look at something like this, which is relatively simple, just how many steps it takes in order to get to a final product. However, if you thought that was the end, nope, not even close. You still need to package the thing, put it up for sale, and then ship the thing. And as it turns out, that takes a lot of time too. Shipping boxes can be kind of expensive. So here's a pro tip. What you do is you search for what you want in Google, you click on Amazon, you start searching all the stuff. You do not buy anything. Just look at all the prices, click on all the things, you get the bots smelling you. And then you come back like a day later, and what you'll find is that the bots are probably going to offer you up a better deal for the same things that you were looking at the day before. I don't know who's looking at who, but I think it's possible to work the system. Now that I had some boxes, I just needed packing material, ended up wrapping this in cellophane, and then putting just scrap newspaper around it. This was during the election, so there was plenty of scrap going around. But here is where I ran into a big problem. As it turns out, not all junk mail weighs the same. So when you package the part, some of these were coming in a little bit too heavy. And as it turns out, if I was 1 ounce too heavy, the price of shipping internationally would go up from expensive to really expensive. So I desperately needed to find a way to make the package just a little bit lighter. This is the original package. a little bit too heavy. Here's what I came up with. It's the exact same box, except for I cut the tabs down just a little bit. And as it turns out, this amount of material right here would be worth $10 per package. This really doesn't feel like $10 to me. So a tiny little change like this had a major effect on shipping. And as it turns out, a slightly lighter product will have this exact same effect. So this right here is the best example of how just everything is connected. From the design, to the operations, to put the thing together, to ultimately shipping it out the door, it all matters. And it all comes back to the exact same equation. How many steps does it take? How much material is used? How much does it cost to ship? And if all of that works well together, then you end up with a price that has a little bit of margin, so you can make a profit in the end. So here it is, the completed part. This is what I put on my Etsy store and I sell at $30 a piece. And there's two burning questions that you probably have. One, how much money do I get to keep from that $30? And the second thing is, how practical is it to use a 3D printer to make something like this? Well, let's take a look at the money. So when I add up all of the costs, such as printing the unit, or adding all of the fasteners and paint to it, add in the shipping and the fact that Etsy gets a small cut for me using their store, plus the fact that I have a little bit of tax, in the end I end up keeping about 50 cents on the dollar. So in my first batch, I sold this for $900, and therefore kept $350 for myself. Which, in case you're wondering, yes, I've already spent that money on upgrades for future videos, such as a new shotgun mic to hopefully fix the audio and make it a little bit nicer for you, and a resin 3D printer, plus the laser engraver. I might have spent more than I made, hence the second batch of sweepies. But now for the big burning question. Does it make sense to use a 3D printer to produce something like this? Well, for a small batch like I'm doing right now, which is 30 units every month and a half, 2 months or whatever, yes, I'm not gonna find anything more inexpensive than a 3D printer to produce this. It's awesome. All I do is load the filament, press go. It is probably the easiest step of all the steps it takes to actually sell this thing. However, if we start to look at this from a full-time perspective, you can see that things are going to be a little bit different. So let's say I was making these 8 hours a day, 5 days a week as my full-time job. Considering that it took my first batch here about 34 minutes on average to make one of these, and then my second batch here is down to 23 minutes per unit, I can make anywhere from 15 to 21 of these a day. Now, when we add in the fact that an automated 3D printer runs 24/7, I'm going to need anywhere from 10 to 15 printers to keep up with the production. Based on the amount of power it takes to run that printer, that's anywhere from 1,300 watts upwards of 1,900 watts. And since I'm using 120 volts, that's anywhere from 11 to 16 amps. So yes, it is actually possible in a home like mine to run enough of these to supply me with enough work to do full time. However, very quickly I'm going to run out of wall sockets and power in order to scale that up beyond me. But how much income would that generate for me? Well, as it turns out, when you factor in some inefficiencies, let's say I'm about 70% efficient, I would make anywhere from $19 to $30 an hour producing this. So not necessarily quit your day job kind of money, but kind of equivalent to a day job. So not bad. It is possible to use a 3D printer to make enough stuff like this to earn an income. Though, unless I had a heck of a lot more power to throw at the problem, or was able to make my 3D printers a whole lot more efficient, I'm not sure I would try to scale up a whole business around the idea of 3D printers. However, if we start to look at other technologies that is still technically 3D printing, the equation might change just a little bit. But that's another video for another time. Not only that, there's a lot of things I've got to talk about here as far as how to set up your 3D printer to be automated. If any of that sounds interesting to you, maybe consider hitting the subscribe button, because that's going to be definitely a topic I talk about here in the future. At any rate, that's all I got time for today. Thanks for watching. Have a great day.